Matrices are just slightly more complicated than vectors. To create a matrix, we usually start by creating a vector. Here, I'll create a vector that has elements 1 through 12 using the integer notation. Next, I'll use the matrix function to create the matrix. Whenever creating a matrix, it is helpful to provide the number of rows and the number of columns to ensure that you're creating the precise matrix you expect. You can do this using the nRow and nCol arguments. If you happen to forget to use the argument names, R will try to guess what you meant. It usually does this based on the order of the arguments. For the matrix function, if we specify the number of rows before the number of columns, we get the same type of result. You can also experiment with leaving off one of the arguments. Notice that if I only include the number of columns, I need to specify the nCol argument name if I want to get the same matrix that I got before. The matrix function is very handy in that, while you might specify the complete set of data for the matrix right up front, you don't always have to do this if parts of the matrix will repeat. Here's a matrix with all zeros. We only need to specify a single zero for the entire matrix. We can also specify a partial vector that can be used to fill in the entire matrix. Let's create a 3x4 matrix with values 11, 12, and 13 filled in the entire matrix. In this example, the vector, which had length 3, was recycled until the 3x4 matrix was filled up. Notice that the vector runs down the columns rather than across the rows. If we had wanted to make it run across the rows, we can add a fourth argument to the matrix function. ByRow equals true. We also sometimes want to learn more about a matrix. We might start using the dim function to learn the dimensions of the matrix. Here, the output of dim is a vector of length 2. The first value is the number of rows in the matrix, and the second is the number of columns. We can also apply the length, head, and tail functions to a matrix. The length will return the number of elements in the entire matrix, and the head and tail functions will provide up to 6 rows from the top and bottom of the matrix. If we want, we can specify a second argument in the head or tail function to get a different number of rows back. One last matrix topic to consider is how to select one or more elements of the matrix. Let's return to the matrix that we had at the beginning of the video. Here, it's just values 1 through 12 in the matrix that has 3 rows and 4 columns. Like with vectors, we can subset a matrix to select one or more parts of the matrix. But since a matrix is two-dimensional, we need to specify 2 dimensions in the brackets. For example, if we use 2, 4, we will get the element in the second row and the 4th column. If we leave the column entry blank, we'll get all of the columns, and if we leave the rows blank, we get all of the rows. Just like with vectors, you can use vectors of length greater than 1 inside the subsetting to return more than one value. Using vectors with length greater than 1 to get both rows and columns may produce a slightly surprising result, another matrix. Let's consider the matrix where we specify the rows 1 and 2 and the columns 3 and 4. Doing so gives us back a submatrix specified by these dimensions. Finally, before moving on, one final word on matrix subsetting. If you forget the comma, R will still return a value. Each matrix is stored in R as a vector with extra dimensions. So if we request the third element of the matrix, it counts down the first column and returns the third element. If we specify the 5th element, R runs out in the first column and so goes to the second column as it keeps counting. I wanted to highlight this not because subsetting in this way is a good idea, but just to make clear that it can be accidentally done, and so it's something you need to watch out for. Using the row-column subsetting notation is the preferred method. In the next video, we'll take a look back at the first 6 videos, and also how to access help files for functions inside of R.